Alright, today we're looking at how to solve systems of equations by graphing. And by graphing, that means we're going to be looking at a couple equations, like this one and this one, putting them together on a graph and seeing at what point do they come together. And that's what it means to find the solution for a system of equations. So solving them means at what point do the two graphs connect or intersect with one another. Okay? So to do that, essentially what we want to do is you take each individual equation and you're going to graph it. Now in this case here, we can see this is going to be in slope-intercept form. So you can see with the y equals 2x plus 3, you're going to put that point at the y-intercept of 3, and then you can use your slope to kind of go up 2 over 1, and then down 2 over 1, down 2 over 1, and then you're going to draw your line. For the next one here, we can see the slope-intercept, the intercept's at -1, so it becomes right there, and our slope is 1, or 1 over 1. And so again, we're going up 1 over 1, up 1 over 1, up 1 over 1, or down over, and again until they come together. Now eventually, when you draw these lines, they do reach a point where they seem to connect here at -4, -5. So we call that our solution to these two equations here found by graphing. And to check that, to see if that's accurate, what you would do is you would take your equation, both equations, and you replace the x and the y with the values you found in your solution. If it stays balanced, then it does work out just fine. So if y is -5 and x is -4, we plug in that one here, we can see -5 all the way down. So we plug in -4, and let's see what happens. The question mark, does it equal? 2 times -4 is -8, plus 5, plus 3 is -5. So because -5 equals -5, that makes sense there. And over here, do the same thing. Y is -5, x is -4. So we're going to have -5 all the way down. Here we end up with -4 minus 1, so -4 minus and -1 is going to be -5, and that works there. So because that's true for both things, both of the equations, that the solution of the system is -4, -5, and we solved that by graphing. Let's do another one here, okay? Because again, it just takes a little practice to see what they're talking about. So this first equation here, we have a y-intercept at +5, so we're going to go here, we have, notice we're counting by 2, so 2, 4, so 5 is going to be right here, alright, and our slope is 2 over 1. So we're going to go down to, it's a little weird here because we're going halfway, so down, up, we'll go up 2, 1, 2, over 1, so we're kind of there actually. We're going to go down 2 over 1, we're there actually. Down 2 over 1, we finally get to the line there, right? And then down 2 over 1, down 2 over 1. So this is what our line looks like for this first graph here. Okay, we'll get that lined up. It's good to use a ruler for something like this because we want to find out where they're going to cross. So I'm going to draw that line about there. And for our next one, we have a y-intercept at 8. So 2, 4, 6, 8. So there's 8 right there. And our slope is -x, so -1 over 1. So we're going down 1 over 1, which means we're right there, and down 1 over 1 right there. So already I can see that with this one here, our solution appears to be right there, doesn't it? That's where our solution looks like it's going to be, which is here between 0 and 2, which is 1, our x value, and our y value is going to be up 2, 4, 6, looks like 7. So our solution looks like it's going to be at 1, 7. So let's take a look and see if that works there. So our first equation, we have y equals 2x plus 5. So if y is 7, we'll say 7 equals 2 times the x value, which is 1, plus 5. Well, 2 times 1 is 2, plus 5 is 7. So 7 equals 7. That works great. Let's check the other one out here. We have y equals -x plus 8. Again, y is equal to 7. negative x will be negative 1 plus 8. So 8 minus 1 is 7. 7 equals 7. That works. So our solution for the system by graphing is going to be 1, 7. So it does work. It's just a little funny with the graph. You want to be very careful as you draw that out to make sure you get it right. Okay? Let's try one more example here. Let's go down to number 4. Okay? Go to number 4. We have, first of all, our y-intercept is at positive 4. So 1, 2, 3, 4. There's that one. And our slope is at negative 2, which means negative 2 down 2 over 1. So 1, 2 over 1, 1, 2 over 1, 1, 2 over 1. And again, there's no limit to how many you do. You can do as many dots as you want to do. I like to do as many that I'm capable of doing, just because it just makes my line a little bit straighter, helps me see some more points, maybe helps me find those solutions faster. And for the next one here, our y-intercept is at 3, so 1, 2, 3. And our slope is at negative x, negative 1. So down 1 over 1, down 1 over 1, down 1 over 1. I also go up 1 over 1 as well. And we can see that we're going to cross right away. And our solution is going to be right there. That's where they cross. So we're crossing at 1, because that's the point here, and 2. So our solution is going to be at 1, 2. And again, to check that out, what we would do is we plug that in to see if it works, and if it does, then it makes sense, and we're going to assume that it does for right now. Okay? But that's how you find your solution of the systems of equations by graphing. All right. So today's work is going to be the same thing. You're going to find the solutions to solve systems equations by graphing, and there are 5 problems, and you're going to do all 5 of them. So good luck on those, and we'll see you back here for the answers in just a moment. All right, let's solve some systems of equations by graphing. All right, so the first one here, we have a y-intercept at 4. So we'll go 1, 2, 3, 4, plot that there. We have a slope of 1 over 1. So we can go up 1 over 1 if we choose to. We can also go down 1 over 1, down 1 over 1. So we have a nice line right here. Looks something like this. So there's our first line. Our next one, we have a y-intercept at negative 2. So that goes right there. And our slope happens to be negative 2, so negative 2 down 1, so down 2 over 1. But I want to go the other way, so I'll go up 2 over 1, up 2 over 1, up 2 over 1, and we can already see where we're going to cross our line at there. So let's graph that here so we can visually see it together. And we know that our solution looks like it's right there at that spot, which is at 1, 2, negative 2, and up 1, 2 there. So our solution is going to be at negative 2, 2. And again, to check it out, you plug it back in and see if it works. Number 2, we have a y-intercept at negative 1 here, and our slope is 5 over x. We're going to go 1, 2, 3, 4, 5, and 1. We can also go down 1, 2, 3, 4, 5, and over 1, so we're kind of off the chart there. That's okay. So that's my first line. Looks something like this. And our second one, our y-intercept is at 10. Oh boy. Well, we can see this is going to be a little issue here because 10's off the chart, isn't it? So we could recalculate that and say, let's recalculate. I mean, 10, I don't have space. I can go 1, 2, 3, 4, 5, but I only go to 5. So because it's too big here, let's make these equal to 2's. Okay? So I'll make my slope here. My first one's going to be here at negative 1. So now I'm going to go up 5. 1, 2, 3, 4, 5, and over 1. So there, and I go down 5. 1, 2, 3, 4, 5 over 1. So like that. Not quite as pretty, but get the idea. Alright, and now we'll go 10. So we'll go 2, 4, 6, 8, 10. And now we're going to go, this is also up 5 over 2, so we'll go down 5 to 2, 4, 5, and over 1 here. And then go down 5, so 1, 2, 4, 5, and over 1 here. Alright, so here we go like that. And we go like this. Okay. So, this is an interesting equation here. Because here we have two graphs that have what? They have the same slope. Now because they have the same slope, they're going to be going up and over the same amount every single time. They happen to have a different starting point. One's at -1 and one's at 10, but they're always going to be going the same direction, the same up and over or down and over, no matter what you do. Because of that, they're never going to intersect. So this would be one where we would say there is no solution. No solution occurs when the graphs, the two equations, never cross each other. And so when they have the same slope like this, that's going to be the case. All right. Number 3. And probably if I'd gone over that in your samples, I notice that now that I'm looking at it. In this sample here, we see that's -3, -3. Same slope. This would be a no solution one. Sorry about that. So if you struggle with that a little bit, that's why. Oh, gosh. All right, so let's move this one around a little bit here. Let's make this equal to y equals, I'm going to add x to both sides, so x minus 1. So we have y equals x minus 1 and y equals x minus 1. This is going to be the same exact line, isn't it? So we're going to put a point right here. Our slope is up 1 over 1, up 1 over 1. Okay, so we have one line that goes right here, and another line that's right on top of it. Now because the lines are on top of it, we would say there are infinite solutions. Why are there infinite solutions? Well, because they're on top of each other. Every point along the way is a point where they're in a sense intersecting or touching each other. So it goes on and on forever when the lines are exactly the same. Kind of a weird one there as well. Okay, number 4. Alrighty here. So here we have the first one, -3 is our y-intercept, 1, 2, 3. And our slope is 6x. We're going to go up 6, 1, 2, 3, 4, 5, 6, and over 1, or something like that. We'll draw a nice little line right there. So that's our first line. And the next one, y equals -3. Alright, so we're going to go y equals -3, 1, 2, 3. So when y equals -3, we have this line that looks like this. Lovely. So it's just a straight line like that. And so where do they cross at? They're going to cross at 0, 1, 2, 3, -3. That becomes our solution for that one right there. So again, a little odd. Sorry, it's just kind of how it works here. We only have a few examples. We only had one like our practice ones, and then we had a no solution, infinite solution, and this weird one where y equals -3, just a straight line across and 1 point solution there. Okay. If we look at number 5, I'm getting nervous here. There are 33 students in the chess club. There are 5 more boys than girls in the club. Write and solve a system of equations to find the number of boys and girls in the chess club. Alright, so this is one where we have to do a little bit of work here to figure out how this works out. 33 kids in the chess club in total. There's 5 more boys than girls. So if we have students, so if we have girls plus 5 is going to equal the number of boys that we're going to have in the group, right? So the boys is equal to 5 times the girls. Now, girls plus boys altogether is 33. So we have a couple little equations here to work with to begin with. Okay, so let's set this equal to g equals 5 b minus 5. So the girls is equal to b, the boys minus 5, and the boys is equal to 33 minus the girls. Okay? So now we could look and say, well, let's see what I have in terms of a equation here. Well, we could do it with, let's do girls on both sides. So let's go with girls equals negative b plus 33. So anyways, kind of played around a little bit. What we're trying to figure out is where would those cross at there to find out how that would work. I'm not going to worry about it too much. It's already a little bit too weird to start with and not super important for right now. Okay? Sorry. So we're just kind of ignore that one. Been a long day. We'll see you in the next lesson. Okay, bye-bye.